Now you know that in this question they are saying you have given three identical 10 ohm resistors and 12 volt cell. That is what potential difference. Now they are asking, draw the circuit diagram to show how the resistors can be connected with the 12 volt cell so that the total heat produced in the circuit is minimum. So draw the circuit diagram to show how the resistors can be connected with the 12 volt cell so that the total heat produced in the circuit is the minimum. So we all know that in series connection, current is maximum, minimum, everybody. Current will be minimum, and parallel connection, current will be what? Everybody. Current will be maximum. So we all know according to Joule's law of heating, if you take the Joule's law of heating, so we all know H is directly proportional to square of current. Square of current. So if you have taken here, if they are asking, they have to produce the minimum heat. So minimum heat means wherever we have a less current, so heat energy also will produce less. More current, more heat energy will produce. So all the three given 10 ohm resistors has to be connected with the 12 volt battery. In what connection, everybody? In what connection?
Series connection.
We can connect them in series connection. So that is what you have to remember. So now if you have taken the solution, they might be connect like this. So now these three resistors also in what connection? Series connection only. So don't get confused. Both are correct only. Okay. Then the most important question is this one. That is what I already taught you in yesterday's class. Offline class we discussed. So observe the circuit shown below. All the three switches are open. So switch number 1, switch number 2, switch number 3. So identify the switch or switches that on being closed will cause the fuse to blow. So that is what, as I told you. So when, what switches if you close it so that the fuse will melt or blow, they're saying. So that is only concept yesterday we discussed. What is that concept called as? Bypass. So that the current will take what path, everybody? Shortest path. So first, if I close only switch 1, switch 3 and switch 2 is open. So current will come and it will pass through the bulb. So bulb will start glowing and then it will come here. So as it is passing through the resistor, so fuse will never melt. Now if I close switch 1 and switch 2 both, so what will happen? No current will pass through the bulb. So instead of passing through the bulb, so no current will pass from here. It will take this path and directly it will go back to here. So that is what we used to say shortest path. Circuit is bypass. So means no current is passing through the bulb. Bulb is a what? Resistor. So in this situation, the more current will pass through the, like you can see, positive and negative terminal directly connected. Positive and negative terminal, switch 1. Here let me take a fuse and this is the switch 1 and directly switch 2 and directly it is coming. So you can notice it, positive and negative terminal directly attached. So what will happen? By the time it will create extremely low resistance. So more current will pass through that. Then according to Joule's law of heating, H is directly proportional to I square. So what will happen, everybody? The fuse will breaks or fuse will blow or melt. So whatever it is. So that's the reason. So identify the switch or switches that are being closed will cause the fuse to blow. What are the switches? Everybody. Switch 1 and 2. So that is what you have to remember. What about switch 3, sir? Switch 3, no use. So if it will close or open or doesn't matter for us. So what is important only we'll consider. So this is what is this question. Even yesterday we discussed. I have shared the concept also. So I hope everybody clear. Anybody having doubt, you can ask me. So the next question is very important question. Graph based question. So have a glance and try to read the question effectively. So they are saying that incandescent bulb works on the heating effect of electric current. Can anybody tell me what do you mean by incandescent bulb? Practical applications of heating effect of electric current. Second practical application. Anybody tell me what is that? Incandescent bulbs. At least try to guess. I saying you practical applications of heating effect of electric current. Second one, filament of a bulb. What is the filament we are using in the bulbs? Anybody? Yes, please. Tungsten filament.
Tungsten.
The bulbs where we are using the tungsten as a filament is called it as incandescent bulbs. So please write. Incandescent bulbs works on the heating effect of electric current. Write that. So now, when a current passes through the filament of a bulb, it heats the filament to a high temperature, which causes the filament to glow. That is how the light is producing. Now, the graph below shows the variation in the current through a bulb immediately after it is switched on. After it is switched on, the current decreases from 1 ampere at time t is equals to 0 to 0.5 ampere at t is equals to t1. So the voltage of the power supply is 200 volts and remains constant throughout. So that is what. See that as soon as if you on the bulb, how much current is passing through it? Anybody? How much current is passing through that? As soon as if you on the bulb, how much current passing through the bulb? 1 ampere. Understand? So after certain time t1, the current passing through it, how much, guys? Speak loudly. How much current is passing? Anybody?
0.5.
0.5 ampere. So what is the reason behind Mutakshari? Sudden decrease, what you are observing from 1 ampere to 0.5 ampere. Because temperature increases. Temperature increases means something increases. Factors affecting resistance. What will happen? Temperature increases means nobody is there. No. Temperature is directly proportional to resistance. Remember for metals. Speak, guys. So temperature increases, resistance increases. So resistance increases means automatically resistance and current. What is the relation?
Inversely proportional.
Inversely proportional to each other. So resistance increases, current decreases. So that is the concept. When t is equals to 0, as soon as if you press the switch, the current across the bulb is 1 ampere. After a certain time period t, after a certain time period t1, the current becomes 0.5 ampere, and then no change in that. You can see it is constantly it is moving. So that is what it's already attains the maximum heating. So further there is no change in that. Now, based upon the graph, state how the resistance of the bulb filament changes as the temperature increases from time t is equals to 0 to t is equals to t1. Just now see, before reading the question itself, I know the concepts. So now I can easily answer. Now they are asking, you can read the question. Based on the graph, state how the resistance of the bulb filament changes as the temperature increases from T is equals to 0 to T is equals to T1. Anybody? Increases or decreases? Temperature increases, resistance increases or decreases? Everyone? Increases. That's all. So temperature is directly proportional to resistance. So resistance increases. That is the reason. Resistance increasing only, what is decreasing? What is decreasing? Current is decreasing. That's all, guys. Next. What is the power consumed by the bulb when it is glowing as its full brightness? As its full brightness. So where is the full brightness? Anybody can tell me? Full brightness, where it will be? At what current it will be having full brightness? Note this point. Wherever constant, consistency, where the current remains constant, that is the point where they are having a maximum brightness. So that is what. So what is the point? At what current it is having the consistency? Anybody? At 1 ampere or 0.5 ampere? All of you. Yes, please. 1 ampere or 0.5 ampere? Yes, respond.
0.5.
0.5 ampere. So they're asking the current when the bulb is glowing as a full brightness. The current when it is glowing as a full brightness, maximum brightness, how much it is? Anybody? Speak, Ra, how much it is? 0.5 ampere. And what is the supplied voltage? Supplied voltage? 200 watt. Now they are asking, what is the power consumed? So power is equals to V into I. So voltage is 200 into current is 0.5. So what is the answer? What is the answer? 100 watt. Do it. Any doubt? Anybody can ask. Clear? Mr. Johan, yesterday I told you to complete electricity and inform me. Till now, no update. Mr. Nitish Krishna also, you can leave from the meeting. I asked only Kirti Raja and Rohit only updated. No other is informed me. Mr. Ashwin Gokul also. Jolly life. Make it quick, everybody. We'll go to complete it, everybody. Do it quick. Any doubt, anybody can ask me or understand, everyone? Noor, Google, clear this question?
Yes, sir.
Yeah. Make it quick. Next question. This is one of the most important question. So the picture P below shows an electrical tester. Picture P below shows an electrical tester being used to check the electric point. The picture the picture Q is a diagram showing the internal parts of the electric tester. This is the internal parts. So I think you all might be note and you are having in your home also electrical tester. So this is what is the tester which we use to test either the circuit is working or not. Now the question is, give the most likely explanation why an electrician does not get an electric shock when he touches the metallic touch screw and the lamp of the tester glows. So that is what is the first question. Anybody? So what they're saying, you see, now the metallic rod, one end, that is what? The flat type head has been kept into the socket. So current is moving and it is coming. So that here the bulb is there. So it is glowing. And of course, at the last, we are having a metallic cap. Have you all checked it, everybody? So that is actually the person who is testing. He is actually directly contacting, but still he is not affected with any electric shock. What is the reason they are asking? So if you observe the picture, you will find it. So all of you see here, this is what is actually the entire screwdriver. So if you notice it here, they are putting insulated transparent body. That is what outside, no use. Resistor, neon lamp, spring, screw, and metallic touch. So actually this is only which we will basically in contact with us. Now observe this figure and tell me, by seeing this figure, you might understand why we are not getting electric shock. Middle, there is a part before the bulb. Of course, neon lamp is there. It is glowing. But somebody is there to control the current. Anybody? Who is that? All of you?
Resistor.
Yes. So what is the use of resistor? Extremely high resistance. So that automatically what will happen? Somebody will decrease. What is that?
Current.
Current. So remember, the current coming through this screwdriver is actually the same, more current. Whatever it is there in the socket, it will be passes. But if as soon as it will enters into the screwdriver, so here before the neon lamp, there is a resistor who is having extremely high resistance, so that it will allow only less current or required current to glow the neon lamp. So very extremely low current will reach us to our metallic touch. Even we never even experienced that as a shock. That is the concept behind designing of a screwdriver. So between the neon lamp and metallic touch, you can notice it. So before neon lamp, we are having a separate one, a device called it as resistor. Understand everybody? So that is only. So now, so what is the answer here? Very low current. Low current flows through the tester. So why low current? Because which part of the tester prevents the shock when the metallic touch screw is touched? Which part? What is the part which is preventing us from the shocks? All of you?
Resistor.
Resistor. So resistor is preventing us from the electric shock. It will make to flow less current through the neon lamp, so that we can identify. So we are not experiencing any electric shock during that. Do you understand everybody? Clear? All of you? Anything doubt, anybody can ask. Yes, please respond. So this is all about electricity chapter. So now immediately we are going with the next chapter as we have a time. So you can go through that, questions, answers, whatever it is. So you'll find it. So the next chapter is magnetic effects of electric current. So here the deleted chapter concepts also will be there. So we'll avoid it and we'll finish it. So for the first question here is assertion and reason. So two statements are given below. One is, in AC generator they are asking. So it is deleted, we won't talk about it. So, okay. Next, leave it. Next question. This is very important question for us. So even the virtual reality Also, I have shown you this one, straight conductor. Do you remember, everybody? If current increases, then the strength of the magnetic field also increases. Do you remember, all of you? Straight
Yes, sir.
conductor. So that is what it is. So the diagram below shows the magnetic field lines due to a current in a straight conductor. Straight conductor. Now, Hari, am I audible? What happened today? So now, something was done to the current because of which the magnetic field lines changed as shown below. You can see here. Now from here to here, the magnetic field lines are reduced. So what was done to the current? They are asking. What was done to the current? Anybody?
Reduced.
Reduced. That's all answer. Do you understand, everybody? So what was happened to the current? Everyone? Current is reduced. Now you see the question. So what is that? The magnitude was increased and the direction reverse. The magnitude was decreased and the direction reverse. The magnitude was increased and the magnitude was decreased. So what is the correct answer? Magnitude of current will
Decreased.
decreases. So remember, by reversing the current, the strength of the magnetism will never be changes. Reversing the current, strength of the magnetic field remains constant or varies on? Strength of the magnetic field remains
Constant.
same or constant. So only what can change? Direction can change. That is only how to remember. Okay. So next, see that how it is. Next one. So a stationary metal coil is placed in a magnetic field. The strength of the magnetic field varies with the time as shown in the graph below. So this is the magnetic field and this is what? When the time being, the strength of the magnetic field is keep on, varies with the time. So now they are asking, in which of the time intervals is a current induced in the coil? So that is what they are asking. In which of the time interval current is induced, they are asking. So anybody can tell me? In which of the time interval current is induced, they are asking. Anyone? Remember. So if the current, I will say you people. Listen, everyone. Current is only induced. Means actually this concept is deleted. Induced current. So we are not having. So but I am saying you for extra knowledge. Current is generated or induced in a coil only when you are seeing there is a fluctuation. If you see a constant graph, then no current is induced. Note it. If this question is deleted, but still I am saying you, wherever you see a increasing graph or decreasing graph, it is indicating current is generated or induced. If you see a parallel graph, then no current is induced. Now, based upon that, you tell me the answer. So, which region the current is induced? Try to guess at least. If you notice it here, from T2, you see that it is parallel to x-axis. So, no current. And T4 also parallel to x-axis. No current. So, what is the answer? Anybody?
T1 and T3.
T1 and T3. That's okay. So just learn. If you don't know also, you can, but remember this. So if it is parallel, constant means no current will generate. Always it has to be fluctuate. That is what it is. So this is what is the question actually, the diagram also. So this is also deleted. Induced current it is. So we don't have. So we don't need to find about it. Okay. So next, a DC motor, deleted question. DC motor, deleted. We don't have. So we don't need to worry about it. So next we'll go with this question it is. So in 1820, the first piece of magnetic effects of electric current, scientist. So Hans Christian Ørsted, even the strength of the magnetism, units of strength of magnetism is Ørsted, discovered that a magnetic needle is deflected by a current carrying wire. So for many years, he has expected to find a connection between electricity and magnetism. The story of magnetism I have taught you while I started this chapter. Do you remember, everybody? Actually, he wants to prove that no relation between magnetism and current. But unfortunately, he found. Do you remember, guys? Everybody? Yes or no? That is only the story you can see. Before his discovery, Oersted had imagined the magnetic field to be a straight line along the direction of the wire. So with the north pole at one end and the south pole at the other, this was a major reason why he took so long to discover electromagnetism. The figure below shows how Oersted would have arranged his wire and magnetic needle in his early experiment. So this is what is the imagination, how he has been arranged experiment. 1,000 times I have taught you people in what way. If you want to see the deflections in a magnetic compass, you have to place how parallel or perpendicularly to the current carrying conductor. Everybody, you have to place how parallel or perpendicularly to the current carrying conductor. All of you, please respond. Even the first lecture I have taught you, check your classworks also. If you want to see the deflections in a magnetic compass, you need to place the magnetic compass parallel to the current carrying conductor or perpendicularly to the current carrying conductor. Anybody? ಯಾರಿಗೆ தெரியாதா?
Parallel to the current carrying conductor.
Verify your classworks. You have drawn 3 pictures. You can check it. Deflection towards to east or west, and next no deflection where the magnetic compass is perpendicularly to the current carrying conductor. Have you checked it, everybody? Yes or no? So that is what. So this is the diagram of Oersted's, expected diagram of Oersted's, where he has been connected, means no deflection has been noticed. So it has been placed perpendicularly. You can see here, perpendicularly. So no deflection. So now the question is, draw a diagram to show the observation that Oersted would have expected when switch on the current if his hypothesis has been correct. So draw a diagram where the current, his diagram is right. So by the time you have to draw how deflections. Anybody? Magnetic compass, modified magnetic compass, how to draw? Parallel or perpendicular?
Parallel.
Parallel. So you have to redraw the circuit and just you have to make only magnetic compass. You have to draw a magnetic compass in such a way that, okay, so north pole and south pole, north and south will. So you have to draw like this. North, south, remaining entire circuit is same. So that is you have to remember. So why means current is passing from here. You can check it. Current is passing from. You can see it is coming actually. So moving, going, going, going and going and going. So that is what it is. So positive to negative. So that is how it will be passing. So what will happen? Direction of magnetic field. Check it, everybody. So when the current is coming down, magnetic compass deflections. Have you checked it, everyone? All of you? So the deflections towards to the right or left or clockwise or anti-clockwise. Verify. When the current is in downward direction, what will happen, everybody? Right hand thumb rule. Apply Fleming's right hand thumb rule. So what will happen? It will be deflecting towards to the, yes please, clockwise or anti-clockwise?
Clockwise.
Clockwise. Please remember that. Next. Based on our current knowledge of the magnetic field around a wire, explain why his experiment failed. What is the reason? I already explained you. If the current carrying conductor is like this, if magnetic field already placed perpendicular, so what will happen? No force will be experiencing, because we all knows that The magnetic field due to a current carrying conductor always perpendicularly to the wire. So since already needle is placed perpendicular, so what will happen? Everybody, it will not get deflected. The force, the influence of the force not deflected. Understanding the magnetic compass. So that is the reason you have to place. If you want to see the deflections, you must need to place how? Parallel to the current carrying conductor. That is what you have to remember. Either top to bottom or bottom to top. This is very, very important. So why can't you place perpendicularly? Because already the magnetic field, you all should remember, magnetic field always perpendicularly to the direction of current at any point. That is how even I have given you the diagrams also. So you might be remember, when the current is clockwise, anti-clockwise, so we'll make it actually three different, like we can 4 different points. So it is like, if it is the current is passing upwards or downwards, by applying the Maxwell's right hand thumb rule, or simply you can say right hand thumb rule, will find the direction. At every point you have to remember that the magnetic field and direction of current both are perpendicular to each other. Clear, everybody? All of you? That is the reason it has been already, if you place in perpendicular, so no influence. If it is placed parallel, then it will experience the effect of magnetism. So that is what you have to remember it. So I hope you all understand this question. Very, very important question. So please learn. Next question is very important. So such a beautiful question it is. So if you observe the figure, don't read the question. Everybody, I'm giving 10 seconds time. So all of you observe this figure and tell me what is wrong with this. Anybody, let me know. Okay. So observe Madhu's and Rahul's circuit shown below. What is the difference you are observing, guys? One by one, try to tell me. What is your differences you are observing? Anybody? Yes, please.
Sir,
Nimish will say. Wait. Nimish and Pugal will say. Yes, Pugal and Rohit also. What is the difference you are seeing? My second meeting, everybody join. You will experience, I'm saying you promise, new questions, varieties of questions, definitely you can. So you can see that magnetism. Yes, please. This is Madhu circuit. Yes, Pugal, tell me what is the differences you are seeing from Rahul circuit to Madhu circuit?
a neutral wire switch is there.
Yeah, very good. Ma, that is only important point. Neutral wire, Mr. Madhu connected switch to the neutral wire. Rahul connected to the switch to the live wire. Very good. So we all knows that which is current bringing, which is current taking out. Who will bring the current and who will take the current? Everybody. Who will bring the current? Live wire. Who will take the current out? Neutral wire. We have studied or not? All of you. So meeting is going to end, join back. So this is a question. Now, in which circuit will the bulb glow when the switch is closed? Explain why. So which one? In which case the bulb will glow? Anybody?
Second case.
Second case. Why, Amma?
Switch is placed near the lead wire.
What? That is what I am saying. What is the conditions for glowing the bulb? What is the conditions for glowing the bulb? Circuit must be closed. So wherever I place the switch, what's wrong in that? If I place to the neutral wire or live wire, if the circuit is closed, bulb will glow. Do you understand? Hasani, you're only saying. That's the reason I said. Observe the figure very carefully.